Hi, Max. Hi, Matt.
Hi,
Hey.
Sorry. Hi, Matt. Nice to meet you. Congratulations, Matt,
You
with
too.
releasing .NET 5. And also,
Thank you. Yeah, it's very exciting.
Yeah, and also, it was a great presentation at .NET Conf. I think it was 2 weeks ago or maybe more. It was a great demo.
Yeah.
Yeah.
Thank you.
Yeah. So
yeah, we'll be showing some of the same stuff
Mhm.
today. So.
Okay, but I believe that you have something else to add. Especially, you're welcome to add
Absolutely.
Yeah,
all the low-level
congratulations
details.
on this event.
Yeah, and technical implementation details and things like that. Our audience is really exciting about all the technical details. So I will go silent
Great.
as of now and let you talk. Please go ahead.
Oh, thank you. Yeah. So, are we seeing my screen right now? Not that it's very.
Not yet. Yeah.
Not yet. There we are. That's not a very exciting slide, but the idea today is to talk about design of C# now and into the future as well. We have 75 minutes together, or we started on 75 minutes together, and I would like to ask that you bring your questions right away. Let's not have like a Q&A session at the end, because it's more fun if we're having a conversation as we're going. So whenever you see something, ask your question. It will be read aloud to me, and I can and I can answer it right there. We'll spend most of the time, or a lot of the time, inside of Visual Studio, and it's easier to take those questions when we're right in there and writing the code that the question is relevant for. All right. So before we get into the weeds, let's talk a little bit about how we think about C# language design. So we have actually a language strategy. You can see the URL there, and I encourage you to go and have a closer read that actually describes how we think about when should we put something new into C# and how should we do it. I want to summarize it quickly here, just to give a context for the for what we're about to see. So I can kind of boil it down to 3 points. The first is that C# is a mainstream language, and it has millions of developers. But we do want to be fairly aggressive or eager about evolving the language. The developer landscape evolves pretty rapidly, and the kinds of domains and challenges that you face as a developer change over time. And programming language has to follow along, and it has to be useful for these new kinds of challenges. And so we're fairly eager to be a language that you don't just use for your last project, but also for your next project. So we're eager to innovate, and so C# evolves fairly rapidly. That does mean that we add more things. We can't take things out, because then we break people's code, and so the language grows. We try to do it in a way that is as respectful to the spirit of the language as it already is, and has minimal impact, so that we can keep growing our language for a long time and don't kind of bloat it into out of existence. But we do want to fairly aggressively evolve. Now, the next thing is that C# is being used for very many different things. It started out as this app language for the Windows, essentially, right? It was mostly for building apps in Windows, and but of course nowadays that's only a small part of what it's being used. It's being used in every kind of domain. It's being used in Unity for developing games and all kinds of cloud stuff, fairly low-level stuff now as well. So you're seeing C# being used in a multitude of different domains, and that means that when we evolve the language, we have to kind of keep all those domains in mind and not focus specifically on on certain things. So we try to keep the improvements on the general end, things that will benefit many people. And then finally, another place that we've moved quite a lot as a language is that we used to be, like many Microsoft technologies, very closed, right? Nobody in the C# user community would know anything about what was happening in the next version of C# until we came out at a conference and said, ta-da, here's what we're doing. This is what you'll get in a couple of months. We made all the decisions in a closed bubble. And that meant that we didn't get a whole lot of feedback. Now, of course, it's a completely different game where C# is not only being developed and implemented in an open source fashion, but even the language design is open source. We have a language design repo that we put where we keep all the artifacts that relate to language design, including summaries of all our design meetings and including where all the proposals evolve and so on. That's its own GitHub repo. As a matter of fact, I can show it to you. This is github.com/.net/C#lang. We have meeting notes, we have the proposals, we have a draft of the spec. It's a little dated, but we're working on that. And there's discussions where people can take whatever thoughts they have and discuss them freely, as well as issues where we work on the more fleshed out proposals. It looks like someone has a proposal related to the records that we'll be talking about later today. This is something that will then be discussed by the C# language design team and so on. So we have a very strong feedback loop with the community. But at the same time, we need to make sure that C# it doesn't just become a pylon language, like a kitchen sink language with everything that's being proposed and everything that might be useful in some scenarios. So we have a language design team that is long running and consists of a few people that talk a lot. Like we meet for 4 hours a week and to make sure that the things we end up deciding to do with C# are in a very that we do it in as consistent a manner as possible. That there's sort of strong leadership about these are the most important things to do in C#. Strong and centralized leadership sometimes is a good thing. All right. That's it for slides right now. We can come back once we start talking about things that don't exist yet. We can come back to the slides. But for now, then let's go and look at actual code. So as was mentioned in the intro, we just shipped .NET 5, and with .NET 5 we shipped C#9. So what's in C#9? I will show some of the features, some of the more general ones. There's actually a talk about .NET 5 later by Raffaele that has a few more of the C# features that have more to do with sort of the .NET end of things. So I encourage you to go and look at that talk as well. For now, let's look at a good old C#8 program here. This is a simple program, has a main method to run your source code, creates a person, the classes are down here, very simple demo program. The first thing that I want to say as an experienced C# programmer, you probably don't notice, but anyone coming to C# for the first time will notice is, well, why do I have to write all this stuff before I can start writing my main program? What is all this goop that I have to say before I can say what the program does? That's a common question that people ask themselves, and we've sort of said, oh yeah, but that's just how things are. Don't worry about it. That's just something you have to write. Well, why? Why should we make people write that? In C#9, we said, well, let's not force you to have the main program be a method of a particular name inside of a class, inside of potentially a namespace and so on. Let's actually take all that away and allow you to write your main program at the top level of a file and just say, write some statements right here in your source code. This is top level programs or top level statements. So this is the source code we had before. Just at the top level of the file, put your usings, write your program, and then any classes or namespaces you have in the same file, they come after. People often ask, so I can head that off at the fort. Well, what do I need to then call my file something special, or like? And the answer is no. The compiler will complain if you have your top level program, if you have a top level program in more than one file, and if you have it in exactly one file, then that's obviously the one way you wanted it. So it doesn't matter what you call the different files, the source files. You just put top level statements in one file, and that's your program. Of course, you can still do it the old way, but the many of the things that you would think you would need an old-fashioned main method to do, you can also do with top-level statements. So it's going to be fairly rare that you need to actually write a full main method. For instance, if you want to access the args, which is a common parameter array to the main method, you can still do so. Like I can go and say args 0 because we actually put a magic variable in scope for the top level program called args. That is this array of strings. So I could do that if I wanted to. Let's say that you want to return an error code at some point. Well, you just return 1, and now it's not a void returning, but an int returning main program, returns a status to the console. You can just do that. If you want to do something async in here, await task.delay. Again, you can just await things. You don't have to you don't have to figure out which particular signature of main method do I need today. You just write the things you need, and then we make the right entry point for you transparently. So we think that I mentioned sort of the newcomer to C#. It's a lot easier now to start out just writing statements, and then maybe write some local functions. You know, this here is a local function in the top level program. So you can write statements and functions first, and then you can learn about classes and stuff later. But it's not just like a feature for beginners. This is just making programs smaller and terser and easier to look at. And that's a theme that we keep coming back to. This kind of thing is actually very clunky in C#. It's always been very clunky in C#. Other languages maybe do a better job on doing this in a simple fashion. Why don't we simplify this? And this is the thing that we chose to simplify in C#9. So I wonder if questions have showed up at this point around this feature.
No, I think that some people have already seen this based on my experience from DotNext. .NET. I can't pronounce .NET anymore. Yeah, saying dot because I always pronounce .next. Okay. Yeah. So
.next.
Yeah.
Okay.
Yeah, not yet.
Well, let's make sure that we do get through the. I'm going to show the same features that we showed at .NET Conf because not everyone might have gone to .NET Conf yet, and this is an opportunity if you had thoughts or questions about it to get more into detail with them. But that said, yes, we'll also get to some other stuff. So. With that, then let's move on and let's talk about immutability for a bit. So you might notice that the way that I create the object here is using an object initializer. I'm not using constructor parameters to pass in the data. I'm using an object initializer. And what we find is that object initializers have become a very popular way of creating new objects. It's nice for the person who are declaring the types because they don't have to write extra boilerplate to write trivial constructors and keep them updated when the type evolves and so on. They don't have to do cumbersome passing of parameters from the derived class to the base and so on. So it's very nice and simple. And on the creation side, the syntax is really nice because you see in source code what gets initialized with what. You don't have to like remember the order of arguments, not when you're writing the code, where at least you get parameter help, but also not when you're reading the code. So object initializers have become this runaway hit in and many companies, you know, they actually mandate that this is the style that's being used for creating new objects. They have some downsides as well, but they, as a supplement to constructors, they're really, really useful and have become very popular. So on the other hand, a thing that has become increasingly popular, and we're going to spend a lot more time on today, is immutability. Not being able to mutate your object. And that's something that we've also done a few features for over time. For instance, a couple of versions after we added auto properties or automatically implemented properties, we also added the ability to not have a setter in them. You can just have getter only auto properties, and now you have described an immutable class, and we can talk a little later about why and how would you use immutable classes, but it's certainly easy to do. The only problem is that object initializers, they rely on mutability for how they work. They literally work by creating a person, then assigning to the fields that you put inside of the object initializer curlies. That's just the semantics of object initializers in C#. Because back when we introduced them in C#3, you know, objects just tended to be immutable. That was just how we rolled back then. So now we have these two different trends in the language that are rubbing against each other and are not working well together. Object initializers and immutability don't coexist well. That's something we wanted to fix in C#9 because we really do see a rise in immutable programming. So the way we ended up fixing it is to say, well, there's a new kind of accessor in properties that's called the init accessor. It's a setter, but it's a special setter that can only be used at initialization time. So you can see that now I can assign these properties again in the object initializer. But if I try to do it after, if I say person.lastname equals something new, try to mutate it, and we have usually have Scott Hanselman who's trying to hack the object here as the villain in this story. We don't let you. Essentially, these are mutable only up until the end curly. So init only properties are the thing that lets you express that, yes, my object model is immutable, but object initializers are allowed. And so I would expect that, so everyone who wants to allow object initializers now have this ability. And it's not just to go a little deeper than we usually do here, it's not just auto properties that can be init. Init is a regular old accessor modifier, and you can write your own properties and also declare your own init accessors as well. And when you do, because init can only be called at initialization time, we allow your init to, for instance, mutate read-only fields inside of a class. So let's say that there's a private string first name here, and for some reason you want to write your property manually. Well, you can write an init accessor. We want to make it read-only because it's immutable, and you can write an init accessor that sets that read-only thing, first name equals value, because it works just like a setter, but it because it can only be invoked when the object is being created, let's just fully implement it here. It has access to mutate the read-only fields here. Did a question just come in?
Yeah, and we have a question from the chat. A really clever one from my point of view. Grey Ghost is asking if init setter is serialization friendly, and what about Newtonsoft.json or dataconstruct.serializer? And from me, I think this question might be asked in more general form: is it reflection friendly, or what kind of reflection based code might be affected by this change?
Right. So that is something that we were careful to think about when we decided how to implement init under the hood. So the init is still a setter under the hood. So when you write an initter, you actually get a setter, and then we put some stuff in there that prevents the setter from being used by other compilers. So you can't. So like an old C# compiler or a compiler of a .NET language that does not understand init setters can't, we use what we call a modrec, to be very technical, to prevent it from being just called by other compilers that don't understand what init is. However, because it is a setter, reflection is happy to use it. Or you can circumvent the protections with reflection. So you're like, isn't that unsafe that you can abuse a setter with reflection that's supposed to only run at initialization time? And yeah, it's a little unsafe, but the same is the case with read-only fields. You can also set read-only fields with reflection after the constructor has run, right? And so read-only fields are generally reflection or specifically deserialization friendly. And so init only properties are as well, or init accesses are as well. We essentially allow a hole of the same size as we already have in the runtime type system, if you will.
Yeah, I remember that. I'm not. Yeah, makes sense. I remember. I'm not sure if it's the case for .NET Core, but in .NET Framework, it was even possible to create an object without calling its constructor. I think it was internally used for binary serialization or something, and I was surprised to know that it was even possible.
Yeah, I can't remember if that's still possible in .NET Core either, but yeah, there are definitely there. I mean, that's a thing to remember. The core type system of .NET is completely safe at runtime. Like the runtime will protect you from accessing a member that isn't there. That's like core type system stuff. But many of the other things that we check at compile time, they're only sort of safe, right? They compile into something that if you use reflection, you can get around it. And we try to at least make these things safe at compile time, even to lower versions of the language, right? So that's what I've said about the init property, for instance. You can't assign to an init property at all if you use an older C# compiler. We put these protections in. We use modrecs and things that poison these things for older versions of the language, so you don't use them wrong. But that's just the compiler. If you get to runtime, there are many things you can do, and we just sort of accept that.
Yeah, you make sense. Shall we continue? Yeah.
Okay. Yes. Yeah. Let's do it. So I think with the read-only and stuff here, I think that's probably what I wanted to say about the init feature, and that's sort of how can you be immutable and still allow object initializers? Now, the next question that people have about immutability, not everyone's used to programming with immutable data, and it might be worth talking a little bit about why you want to do it and what are the kinds of, how do you do things when you're immutable, and how do we then support that in C#, right? So let's actually keep this version of the code for a bit. We might want to use it later. So in other words, you know, if I can't change the object, let's say that Scott changes his last name, he gets married or divorced or something, or he just decides to change his last name. How can we change his last name if the representation of him is immutable? You know, how does that even work? And that's a great point, right? What are the programming patterns around immutability? Why do we have immutability? And what are the programming patterns around expressing change when you do? And so to answer the question, why do we have immutability first? Immutability is really useful if what you're representing is not the object itself, like in classic object-oriented programming, where the object evolves over time to represent the state as it is at that time. Instead, you want to represent each snapshot in time of an object state, or of the value of an object, if you will. You want to represent those separately so that you can talk about the timeline itself in the program, right? So think about an undo system, for instance. Many UI frameworks are based on immutability in the sense that each frame is, or the sort of UI tree or DOM of what's presented isn't mutated over time as the UI changes, but you create a new one from the old one so that you can undo and get back to the old one, or so that you can do diffing between the two. We have the whole C# compiler implemented, and the VB compiler actually implemented in something we call Roslyn. And that also represents all the program structures as immutable. There are syntax trees in there. They're completely immutable. You parse some code, you get a tree that represents it, and then you can start manipulating that tree programmatically. It's a C# representation of code, but the way you do it is that you create a new version of the code with some things changed, right? A new version of the tree with some things changed. So that pattern is called non-destructive mutation. And it's really useful. You can also imagine with this underlying the very Visual Studio that I'm using right here as a model, that enables us to like speculatively apply a refactoring, for instance, and then we can show both the new and the old version of the code at the same time. We can even show you the diff, right? If I apply a refactoring, you can see a diff. But because we have a representation of the code both before and after existing at the same time in program time. So non-destructive mutation is, one more advantage I want to call out about that is that if you want to use concurrency, for instance, if you have many parallel threads working on your representation, on your object model, well, they don't have to synchronize nearly as much, right? Because the whole shared mutable state problem goes away if there is no mutable state. Then there's no shared mutable state, right? The state is not mutable, so you can't affect each other through the data representation from accidentally from multiple threads. That's really the point of it. Now, non-destructive mutation then seems to be core. How do I evolve my object model from one value, one snapshot, to the next? That's really about treating objects as values, not as stateful objects. How do you treat an object as a value? Well, in C#9, we have a feature for that, and that's a feature called records, right? So that's how we're going to eventually solve how to do this line of code. So records in C# are classes. It's just a new keyword that you can put instead of class. We're actually thinking about allowing you to even say record class, but we didn't do that in C#9. So this might we might think of record just as a modifier on class, but in C#9, you can't say that. You have to say just record. And it's automatically a class. It's a class like any other class. It can do all the same things as other classes can, except you can't inherit between classes and records, between ordinary classes and records in C#9. Records have to inherit from records. but that's also something we might lift in the future. So think of it as a class declaration that has extra functionality to enable a value-based programming model, one in which we expect you to be immutable and represent a single value. And on the other hand, we give you the tools to treat you as a value. And what are those tools? Well, we talked about non-destructive mutation, so let's start there. We can, instead of doing the destructive mutation, non-destructive mutation is where you create another object from an existing object by changing one or two little bits of it. So we represent that in C# with a with expression. That's a new kind of expression called a with expression. Take an existing object, you with it with an object initializer, and what that essentially means, what that actually physically means, is create a very reliable copy of person and initialize according to the object initializer on top of the copy. So so the record enables the with expression. And we can see exactly the benefit that we saw before. I see questions coming in, but let me just show this bit. If we display the other person as well, actually, why don't we try and run the program? Let's see, build it. Hopefully I didn't leave bad stuff in there. And there you see Scott Hunter and Scott Henselman coexist at the same time here. There are two objects that are like each other, except one was changed according to that object initializer we put into the with expression. Okay, let's hear those questions.
Yeah, let's begin with the first one. So, can records be defined as partial? I think they can, right? As soon as they're classes.
Yes, they can.
Cool.
That works.
Okay. The next one, yeah, I like this question, and it was mine as well. So I know the answer, but please answer it for our audience, and then I'll ask something else. Can records be used for entity framework core models?
The answer to some degree is yes, but just keep in mind that the way the entity framework works is an object relational framework, right? It is built to track changes in objects over time and use that to modify the underlying relational database. And so that doesn't really fit well with immutable programming. So I think it's still up in the air, and I don't have the I have to admit I don't have the details on the current thinking from the entity framework team on this. But it is this is a different programming model than what they're sort of based on with the in terms of update model. But other than that, you know, given that these are still classes with properties, there are definitely some things that carry over, the querying capabilities and so on should be able to work. But how the full thing comes together, I have to be honest, I don't have the full answer to that. And where so that is in the process.
So it's perfectly fine to use them in your select statements, for instance, because there is no harm since there is no change tracker for selecting DTOs, and normally you use object initializers to initialize your DTOs. So I think that's a safe case for using records using entity framework.
I think it should be.
And probably other people can ask Jeremy, because I remember that he told that they have some crazy ideas, and I'm eager to know what they are, because I have no idea how to track immutable entities across your program.
Yeah, so I should also I should ask him that so I can be a little more up to date on it. But by the way, it's important to note that it's not records records really aren't at the core of the problem here so much as immutability. Records don't have to be immutable. All the records do is that they're value-based. You can certainly have a field or a property inside of actually, I forgot to change this one down here to be immutable, right? So you can totally have mutable records, but you just have to be aware that if you're mutable and you have value semantics, then there are some gotchas that you have to be aware of. So it's kind of built with immutability in mind as a common case. But we don't force you to make your records immutable.
Interesting. And there is another good question here. Are init properties required in the initialization block of your objects, or is there a way to make them required?
That's a great question. It's actually in the slides as a thing for us to work on in the future. Init properties are not required. No properties are currently required. It's one of the known downsides of object initializers. And it's actually sort of orthogonal to the immutability of things. Even for mutable object models, it would be nice to be able to mark a property as required, and then you have to put an object initializer and initialize that property, or the compiler will give you an error. That would be a great feature, and we're actually investigating it right now. We're talking about it on Monday in the C# language design meeting, so there'll be notes out about it shortly. But it's a feature that gets fairly complicated when you get into the weeds of it, and so we're still wondering whether it's worth the complication. Right? It's back to those language design trade-offs where, yes, we can design a feature that has this beneficial effect, but is that beneficial effect great enough to justify the complication to the language? Can we design it to where it's simple enough that it's worthwhile putting it in? That's an open question right now. But we are really thinking about making required properties a thing in C#. For now, if you'd want to require something, just make it a constructor parameter. You can still use constructors, just because they have downsides. That allowing things to be required is an upside, and that might be the way for you to go. And we'll actually see some nice things you can do there with constructors in records that are an excellent shorthand in a few minutes' time.
So it sounds more like a type system space than the record space itself. I mean, properties that has to be initialized and properties that has not to be initialized, and so on. And it's so nice to know that you are thinking about those scenarios. And I personally like the approach that you are borrowing features from F#. And is, by the way, F# a playground for the C# team? Because I see so many features borrowed from F#, which are really great. It looks like you're taking the best parts of F# programming language into C# and try to be not that complex as F# is at the same time.
Yeah, I think, first of all, the answer to your question, is F# a playground for C#, is no, in the sense that we don't like put features in F# to see if they would work out in C#. F# has its own design process, and it is a very coherent, well-designed language in its own right. But it's a functional programming language, and there are many, many functional features that we have stolen into C# over time, because, in a sense, the history is on the side of functional programming in a way. Not all of functional programming necessarily, but there are aspects of functional programming that work better in a distributed cloud devices world. Maybe we can talk about that a little again when we get back to pattern matching, but even here also, you're seeing how the classic object-oriented paradigm isn't always the best, especially when you have scenarios where data lives outside of your app. And so we do take a lot of inspiration from F#. And we now, sometimes the F# people get annoyed because when we decide to take a feature into C#, that's a functional feature, then we don't always do it the same way as F# did it. And now we're stuck with two different approaches.
Asyncs.
And we have to figure out,
yeah.
async, for instance, yes. Now we have to figure out how to make them work well together. So we talk about that, and C# has many users. Like most C# users will never need to interact with F#, and so we just have to do what's right for C#, and then sweep it up and make sure that we then bridge to F# the best we can. So sometimes you see the features being different, and records are an example where the features are different in many details, because in C# records have to fit in with the whole object-oriented paradigm as nicely as possible. Records have inheritance, and records have methods, and records have all kinds of things that they don't in F#, because that's important in our paradigm.
Yeah, that's a good point.
But yeah, good.
Anyway, I think that I stole too much time.
No worries. This is all fun. Let's see where we got to. Yeah, so we got the winding all the way back to the with expressions here. So that's the non-destructive mutation is the first of a number of things that records allow in C# that normal classes don't. The next one is something that well, actually, let's stop over for a simple thing. Because records are typically immutable and sort of data-oriented in a way, we decided to give records a fancy toString. So instead of this display person method here, I can actually just write line person object and the other person object, and I get a fairly nice standard toString text on it. So let's go and print that out just so you can see. So it tells me what type it is and what the values of the properties are. So that's very nice. Of course, this is when I say that this is sort of like, you might ask why don't we do this for, I can't get this close. Why don't we do this for all classes? Well, we're sort of depending on you probably being immutable here, in the sense that we don't, if you have a, when you're immutable, it's really hard to create cycles in a data structure. And if you have data cycles in a data structure, it's really bad if you try to write out the whole data structure, because unless you do something really fancy, you're just going to keep writing forever. You're going to be chasing those loops around. So we decided, okay, you're likely not to have cyclic records, so we will give you a value-based toString. Okay. So now we can get rid of the display person thing here. And that kind of leads to, when I said value-based, that kind of leads to the last big thing that records always give you, which is that equality has been redefined to be value-based. So we override the standard equality of objects, which is reference-based, like are you the same object, to being value-based, where we compare recursively all the fields, all the state inside of a record to the other record. Are you the same type, and do you have the same values in the fields? Then you're equal, right? So value-based equal is recursive. So let's try to actually let's try to create an object a record that will be equal to the first one we had. So we could say original person is that other person with last name changed back to Hunter. So that marriage to Hanselman was short and he got divorced, and he's now called Hunter again. And then if we write line out whether they're equal, let's use an interpolated string here. Could call to the equals method. It's an S in there, just make sure we get that in both places. Equals of the person, and then the original person, and that should show that they're actually equal, even though they're different objects. So let's just check that they're actually different objects. Reference equals, calling reference equals instead, which will always compare the object references. Let's try to run this thing. And what you will see, now I didn't write out the original person thing that was changed back again, but you can see that they're indeed equals by value, even though they're different objects. So I think it happens fairly often that you find yourself wanting your objects to actually represent values and for their equality to reflect that. And implementing that by hand is just really cumbersome. And even though it's not complicated in principle, it's very error prone because there's a lot of logic that you have to keep updated whenever you change the class slightly and so on. So just for the implementation, correct implementation of value equality, that records are super useful just for that. Right. Now I'm hearing a bunch of sounds that seem to indicate that we have some questions.
Yeah, the first is, well, I'll try to explain this without writing some code. So the question is, in Visual Basic, we have another semantic for the with block statement, where we can use something with variable and then use its methods inside without need to use the actual name of the variable. It's pretty similar to what import static does in C# language. So is there any chances that statements like this would appear in C# language in future versions?
I think we've looked at this several times earlier. Like, do we want something like the with statement in C# or in VB? And we keep ending up saying no, probably not. So it's, I mean, it does have its uses. It is nifty in places, but we don't seem to miss it very much. We only get asked a little bit about it, and when we get asked about it, we usually don't get examples that are very compelling. So we've mostly probably just resigned ourselves not to do it, which is why we felt good about using the with keyword for something else in C#. Even though for a VB developer that might be a little confusing, it's not too bad because the with keyword is actually also used in VB for applying object initializers, if I recall correctly. So there is some resemblance to that usage of the with keyword in VB.
Okay, so another advanced question from my point of view. I'm not sure if I understood it correctly, but I'll try. So records have another equal semantic, which makes perfect sense for them. And the question is if there is a way to change the semantics for, let's say, strings, because sometimes, well, nowadays we have to put this extra parameter to check if strings are equal or not. So I believe the actual question is if there is a chance that there will be some kind of another string implementation similar to what record is compared with classes, in a way that this behavior would be overridden.
Okay, I hear the question a little differently. Since the value-based equals method is generated for you, it will use the standard equality of strings. Can I have a record that implements equality differently so that it compares strings inside of it differently? And the answer is yes, you can. But now you have to do quite a bit of work, because you can override the equals method itself. In fact, anything we do in records, if you don't like what we do for you, like the members we generate, you can write your own, and then we use that one instead. And so if you want to change how the equality works here, you can just write your own override of object.equals, and that will then be used by everything in the record machinery instead of the one that we would generate for you. So then you can implement your own equals for the strings, but you now also have to maintain equals for all the other members. This is also a trick if you want to leave one out. Let's say you're caching something, or there's something you don't want to be compared in equality. Yeah, you can write your own, but now it's getting advanced, right? You lose a lot of the benefit of having things generated for you manually, but it can be the thing that you need to do at a certain place in your record hierarchy. You need to do something special, and so there is that out, but it's not super pretty, I have to admit. It's not something that we designed a nice feature for. Maybe if we get a lot of requests for it, that's the way to do it.
Let's speculate about this a little bit more, because it can get us to the next question. So what if I wanted to globally override this behavior? So the easiest solution would be to introduce a base record in which I would override this equals behavior for strings, and then I need to inherit this record in all the records from my solution, right? If I need to do it globally.
Yeah, but that wouldn't even do it. I mean, you can't change how strings are compared in general, right? The records machinery, you have to do it for every single string in all the derived classes if you want to. There's no way to globally change the behavior of string comparison. So
I see.
Not that we would need to come up with something where that was, maybe there's an attribute you can put on a member to say use this comparison instead or something. I don't even know what it would look like, but it's not. So that's the thing. The records feature does a lot for you, but it does it in a certain way. And if you don't like the way it does it, then it does diminish the value of the feature. There's no getting around that.
Okay. Also, a tricky question. I think that it's not possible, but still. Konstantin is asking if it's possible to create cycles using object initializers or init properties. Like if I need to create A that is using B, which in turn is using A.
It's probably possible, but you have to be really sneaky. You have to use, you can't do it just with object initializers. You have to do something inside of constructors, I think, in order to make it work. Because the thing about an object initializer here is you can't reference a new object inside of the object initializer. And that's on purpose, right? So I can't take the new person and do something with it as part of initializing that person. So it would have to be something that, a constructor creates another new object and then initializes it to point back to the object that it's constructing. And you have to sort of do it in a constructor that can mutate both an object that it creates and the object that is being created by it, so to speak. So there are tricks that you can use, but it's not easy. And that's on purpose. Okay. And if you go to functional language too, creating cycles is difficult. Usually data is tree or DAG structured. It's acyclic.
Okay. There is yet another question about the equality, but let's keep it for the next post because I need some time to understand it. It's not clear.
Okay. Now. And also, I think we have 17 minutes left, and I think we should make sure we get to where people see a little of the glimpse into the future as well. So, that was value equality. There's a few extra things you can do when you have a record. So why don't we, let me just change this. Never mind. So one thing that I can do in a record that I can't do elsewhere is in all classes, I can write a constructor. And if I explicitly define a constructor, then I won't get the implicit no-arg constructor that we are actually calling up here. Right? This means it's essentially this. So if I declare another constructor, there's no empty constructor, and that's fine. That's the same on records. But instead of declaring a constructor inside the body, I can declare constructor parameters directly on the record itself. So I could say string first name, string last name here. Now I can use these to initialize things. So I can say I haven't actually done it exactly like this before, so let's hope that works. These squiggles are just about the parameters not being used. So you can see now I'm initializing my properties from them. One thing that you notice is that I use exactly the same name, including uppercase letter here. And that's because in a record, if you put primary constructors on a record, there will be a corresponding property with the same name as these parameters, which means that if I don't declare it, the compiler will generate one for me. So I could leave out, well, let's comment it out so it's clear. I could leave out this declaration here, and I get exactly the same thing declared for me by the compiler. So by default, a primary constructor parameter will generate a public init only property of that type and then initialize it from the parameter. So that's why I used exactly the same. You can declare your own if you want it to be implemented differently, like I did here. I can totally declare my own property instead of the first name one that I would automatically get generated, and then I don't get one generated. But of course, if I accidentally, then that's, you know, if I wrote it differently, then we start getting into problems here. That's primary constructors. Of course, now I need to take parameters to the student. I can pass some of them on to the person here and so on. We get into this whole chaining thing that you now have to do with constructors. But it gets really useful. If you want to like declare a very terse little record, because if I'm happy with the init only member generations I get, I don't have to put anything in my body. And actually we can just put a semicolon there in that case, and this declares a whole record with constructor parameters, a property for each of the parameters. We actually even generate a deconstructor in this case, where you can positionally deconstruct the person back into its constituents. We could let's quickly do this for the student as well, so you can see what it looks like. Take those two as well as ID. There we pass the first name and the last name. And we also don't need a body for this one. You can have a body if you want, but we don't need one in this case. There you go. Of course, now I can't create the person like this anymore because now it needs constructor parameters, but you get the idea. Okay, and then the last thing I want to say about records is, I didn't get around to showing it very thoroughly, but these value-based semantics, they're based on the runtime type of the object you're looking at. And so even if I had created a student here and kept it as a person, as a static type person, it would still work. And the with expression would create other students. So things would, at runtime, these students, these new objects would also be students. So we copy at the actual runtime type, and we would copy over all the fields that are statically hidden here at the where the with expression occurs. Even though the compiler can't see that there's a student ID, then the with expression will still make sure that it's copied over to the new object, so that when you rediscover that it's a student, that all the right things will have been copied. And the same for the value equality. It checks all the runtime, all the fields that are there at runtime, not just the ones that are statically visible at the point where you do the equality. And then I should also say that when we implement equality, it's not just the equals method. We also implement IEquatable of the type. We also implement equals equals and not equals operators and so on. It's a like full implementation of equality. Okay, I think we have a few more questions.
There is a discussion here about the previous question, but we decided to keep it for the discussion zone because, well, there are some implementation scenarios which I believe people would like to ask you verbally yourself.
Okay, yeah, let's go to the let's kick the rest of records then to the discussion zone. We only have 15 minutes left. So let's leave records behind now and talk quickly about pattern matching features that we also added to C#9. So if you haven't followed pattern matching at all, I'm sorry, because this code is going to look very strange to you. But this is C#8 code. It's an expression-bodied method where the expression is a switch expression, which you added in C#8. That takes, where each case has a pattern and then results in an expression if that pattern matches. And there are a few ways in which we improved patterns this time. There are no new things you can do with patterns, like no new kinds of statements that patterns can be used in, but there are a few new improvements in patterns. First of all, having to say that I don't care about the specific taxi by giving a discard, that's kind of silly. So now when you're just checking for a type, you can totally do that without saying you're not interested in it. You can just not be interested in it. So that's type patterns. The second kind of pattern is noticing that you have a lot of places where you are comparing to constant values in code. And so we decided to make patterns out of this comparing. So for the delivery truck here, instead of having these three cases with a when clause that has arbitrary Boolean logic in here, let's try to do this as a nested pattern. So when I have a delivery truck, then take that gross weight class, switch on it, and then in the switch body, greater than 5,000 is actually now a legal pattern that gets applied to the value that I was switching on in a nested fashion here. So we can quickly turn this into a nested switch using less than 3,000 as another pattern. Then there's a fall through here for the rest. And we just need to close out this pattern and we're good. So, so this is relational patterns. I just check that the value compares numerically according to the pattern. But this one's a bit annoying. This represents being between 3,000 and 5,000. And I would like to be able to say that directly rather than just relying on having checked both ends, right? So I can do that by using the third kind of pattern that we added, which is a logical pattern. So type patterns, relational patterns, and logical patterns. So what this really means is that I'm greater than or equal to 3,000, and I'm also less than or equal to 5,000. And I can actually write that directly as a pattern. And you might ask, why use and as a keyword and not the double ampersand? Well, that's because it gets very confusing, both for the compiler and also for the reader, when there are all these expressions around as well. And so we decided to use the actual keyword and, or, and not for the logical patterns that combine other patterns. It's easier to, it stands out more, it's easier to read, and less confusing. So now, having turned this into an actual nested switch instead of having that Boolean logic, well, it's a little more readable maybe, but what else do I get out of it? Well, let's say I made a mistake. Let's say that I put 4,000 here instead of 3,000. Then I get a warning now saying, hey, you're not handling all the possible inputs, right? You're not handling the value of 3,000, for instance. So it can tell me if I'm making a mistake, or if I let's say I forget the second part here. Let's just delete that. Now it can tell me as well that this pattern is unreachable. You can't have a pattern that has no chance of running. So as your code evolves, these safeguards will help keep you honest and help make sure that your patterns still make sense, which in a way they can't do with arbitrary Boolean logic. So with that, I just want to quickly show, here's another helper method that it's a big if-else. And there's actually now a refactoring that will let me convert that to a switch expression. And you can see it uses the relational patterns very neatly here to decide a time band enum based on the time of day. So that's what I had for you on pattern matching. If there's a single question or two, we can quickly look at that.
Yeah, have some. So these two are kind of connected. The first is, I remember that in C# 8, there was a weird implementation when even if you specified all the enum members in the pattern matching, it still says that you didn't, because there could be enum that was deserialized. So kind of you have to write down yet another case. So this behavior stands in C# 9 as well.
Yeah, and it's not just when you deserialize or something fancy. Like you can do arithmetic with enums. Unfortunately, C# enums, all the values of the underlying type are valid in the enum as well. Enum are a very old concept, and there's no notion of them being closed. Like so, you can take an enum value, you can add 20 to it, and you have another valid value of the enum type. You don't even have to deserialize to get into that. So we just had to run with that and say, okay, so for a switch on enums, we can't know if you intended for non-name values to be legal. It could also be that they were flags, and anding and oring them together would be valid, and so on. So we don't consider a switch exhaustive even if you hit all the named enum values. So we are considering ways that you can make closed types, both like generalized discriminated unions, I'm just going to dangle that, but also closed enums in the future where you say, hey, it only has these valid values. And in that case, the switch would indeed consider it exhaustive when you mentioned all of those. But that's for the future.
Yeah, like strict enum, probably like yet another magic word, similar to record or something. Mm-hmm. And have you just mentioned discriminated unions? What about them?
Discriminated unions are the functional language alternative to inheritance in a way. They're how you can get sort of polymorphism in a single variable, where it can have different kinds of things, and you can ask what it is with pattern matching. And so it's very nice for describing data types very tersely, and we're thinking about how we can add a feature that does that, like discriminated unions, but works well together with inheritance, which already is the primary abstraction mechanism in C# as an object-oriented language. So trying to solve that is an open issue on our agenda that, C# 10, C# 11, at some point, maybe it took us 5 years to get records. So since we first started looking at it. So let's see when we actually, if and when we find something we want to do with discriminated unions.
Okay, yeah, and it looks like many people are saying that this is the most wanted feature. Discriminated unions. Yeah. So just in case you would like to know, people would love to have them. Me as well.
Maybe we should. Yeah. Sounds good. Well, maybe we should discuss what they should be like over in the discussion zone after. What your thoughts are on it.
Yeah, so is it the end of your presentation, or?
No, I have other things I can show that are more to the. We talked about many future things that I have in slides, but I don't need to show them in slides now, that are related to records and that kind of stuff. But I do want to show one completely different thing, just as an example of some more out there stuff that we're talking about, just to give you like a look further into the future. And there are a couple of things that we're discussing that go deeper into the type system, that are not just like fancy overlays on what we already have, but that are actually new expressiveness in the type system. And here's one of them that's easy to explain in 2 minutes. So that's the idea that interfaces can specify static members as well as instance members. So if you think about the problem of writing generic code that's numeric, generic numeric code, that's super painful in C#. You can't really write a generic method, a generic algorithm that adds elements and does math on them. Like, that's just extremely painful. And that's because you can't abstract over static members like operators. But what if you could? What if an interface could say, hey, there's something called a monoid in mathematical terms. It has a neutral element and then an operator over elements. Wouldn't that be cool? Then let's say that you could do that. Let's say you could specify static members and interfaces, and we're indeed considering allowing this, enabling this, which is a big runtime feature. Then we could say that our own int types implement this interface, and int already has a plus operator, but maybe you publicly or explicitly implement the zeros. You would now have to implement the zero static property as well. And because we have this interface, now you can use it as a constraint on type parameters. So I can write this generic add method that takes t's that takes a t that is a monoid and an array of those t's. And because we know that it satisfies this, then I can call the static property on the type parameter. It knows that it implements one, and I can apply plus on the elements in the array because I know that they're monoids. They have an array, or they have a plus operator. And so now I could call this add-all method on int because int satisfies the constraint by implementing the interface, but you could also implement your own numeric types that implement the same interface, and this generic numeric algorithm would apply to all. So I want to end on that as an example of the kinds of things that are deeper. We can do those now because we're .NET Core, because we're not afraid to evolve the runtime in order to enable language expressiveness. And so this is the kind of thing that you see us do more, like deeply mutate the language and the type system. So with that, we're at time, and I want to say thanks for all the lovely questions. I almost got a little frazzled with all the questions. See you in the discussion zone.
Yeah,
Thank you.
Thank you. It was amazing. Yeah. Thank you, Matt. Thank you, Max. And please move to discussion zone.
Sure.